Well, hello there. Welcome to a continuation of our last lesson. We're going to pick up pretty much where we left off. I know that last one we ended kind of abruptly, so that was a little weird. I know people were unsure what just happened here. So let's get right into the lesson. We talked about steps to solving an equation, and I gave you 2 steps. And always our goal is get the variable alone on one side. That's our goal. If you can keep that in mind, that's what we're trying to do. So please keep that in your mind. So to do that, there are 2 steps that we talked about. Moving the constants, meaning adding or subtracting those numbers, okay? Constants meaning the numbers that are being added or subtracted, all right? And always keeping that equation balanced. That's real important. The other thing that we did was we eliminated coefficients, meaning if there was a number multiplying or dividing our variable, we wanted to get it down to just a 1. And that's what we did in our last lesson also. Well, today we're going to combine both of those ideas. And I'm sorry, I have such a tickly nose today. My grandmother used to say that means you're going to kiss a fool. I sure hope not. Anyway, so today we're going to do those things, but we're going to need to do pretty much both of those in our equations today. So I'm calling them 2-step equations. Where yesterday I gave you one or the other, today I'm going to give you both all in one equation. So if you can see, you'll see here, our goal is the same. Get that variable alone on one side. Our 2 steps here are the same, but I've added some questions inside both of them. And they're the same questions. So don't panic when you see, oh no, she's giving us so many things to think of. No, it's really pretty much the same thing in both of them. The only difference here is this one says now go on to number 2, and this one says go back to 1 or 2 if it's no. So let me explain what I mean. When we are looking at an equation, what I want you to think of, and this is what I do for myself, is I think to myself, and maybe even say it out loud if there's nobody around, to think you're crazy. You say to yourself, what's happening to that variable? And you look at it and you say, okay, it's being, let's say, added to a 3. I don't know. We'll see some examples in a minute, okay? It can be added to a 3 or something like that. So then I ask myself, well, what's the opposite of adding to a 3? The opposite is subtracting by 3, okay? So you're going to do the opposite. I talked about doing the opposite yesterday. Same things, okay? Make sure you're doing that always on both sides. And then when you get that part done, you look at it and you go, is my variable all alone yet? Is there just one letter on one side and an answer on the other side, a number, a constant? If it is, I'm done. Woohoo! That was an easy one. Or, no, I need to go on to number 2. I need to check it out and see, is there a coefficient on my variable? In other words, is it being multiplied or divided by something? And again, I ask the same question. So what's happening to the variable? Say it out loud to yourself if you need to. It's being, let's say, multiplied by 4. Okay? So what's the opposite of being multiplied by 4? It's being divided by 4. Okay? See how you can say that? Don't just stop with the operation, though. I have a lot of students who'll say that. Well, it's being divided. Okay? By what? I need to know what. So say it, all of it. Then you're going to do that to both sides. Step C, you'd see there. And then lastly, you're going to ask yourself another question. Is my variable alone yet? If it's yes, yay, I'm really done. If it's no, well then what's going on and which one do I need to go back to? Number 1 or number 2? Okay. Well, let me show you what I'm talking about. So here's an example of a problem. And my first thing I want to do is if the variable is being added or subtracted, added to or subtracted from, then I want to do that first, okay? We're kind of undoing the equation. It's kind of like a puzzle. So my goal here, as always, is to get the variable alone. And I'm just going to write that down here. X equals something. That's my goal, is to get X equals some number. That's my goal. So, as I showed you last time, if this will help you keep it organized, draw your equation, or draw your balancing line here, and take a look. It says move the constants, add or subtract, using opposite operations, keeping that equation balanced at all times. So how do we do that? Well, first of all, what's happening to my variable in regards to adding and subtracting? Well, let's see. My variable is having 9 added to it. It is being added, and I'm just going to plus sign there, by 9. Okay? It's being added by 9. So what is the opposite operation? Well, to subtract by 9. That's the opposite operation. So let's do that to both sides. All right, so I'm going to subtract by 9 to both sides. And this is where I do an equals line. You don't have to do that equals line, but I like to sometimes. So if I subtract 9 minus 9, that leaves me 5x. And over here, 39 minus 9 is 30. And all of that is still equal. We have done the same thing to both sides, so everything is still balanced. All right, so last question in that group, is my variable alone yet? Let me look. Is x all by itself? Did I reach this goal? No, I didn't. So I have to go on to number 2. Okay, now number 2, we do the same thing. What is happening to my variable? Well, let's look. 5x. That means 5 is multiplying the x. So that's what's happening. It is being multiplied by 5. Okay? Multiplied by 5. That's an x multiplication, not the x as in the letter x. All right. So what's the opposite of multiplying by 5? Well, that would be, I'm going to use the division sign that looks like a fraction. Division, okay, dividing by 5. All right. So now, step C, it says do that to both sides. So divide by 5. Divide by 5. Do it to both sides. Divide by 5. All right? 5 divided by 5 gives me 1x. Remember we did that last time? I showed you that in the last lesson. 30 divided by 5 gives me 6. And that is equal. Now, go back down here. I did that to both sides. Is my variable alone yet? Well, you know what? Yeah, 1x is the same thing as just an x. So x equals 6. Is my variable alone yet? Yes. No. Yes, it is alone. Sorry. I'm getting myself mixed up here. It is alone. We are done. All right? That's a good example of how to do that. Take your time. If you need to rewatch what I just did, please do. Here's a question for you. All right, I'm going to look at that same question that you just did and take it step by step. Because I asked you in that one what would be the first step. So let's take a look at it. Okay, I'm going to draw my line. The first step was, it says, what is happening to the variable when I'm talking about adding and subtracting? Well, 4 is being added, so it is being added to 4. So what is the opposite operation? Well, we're going to subtract by 4. We are going to subtract by 4 right here. And we're going to subtract by 4 right here because the next step says do that to both sides. Okay? There we go. 4 minus 4 is 0. 2x is all we have left on this side. 6 minus 4 is 2. That is equal. Those two things. Next thing is my variable alone yet? No. Go on to number 2. All right, we're going to eliminate coefficients, multiplying and dividing. We're going to look at that. What is happening to the variable? It is being, I'm going to use a dot this time, multiplied, that's a dot, believe it or not, that is really a dot, there we go, multiplied by 2. So what are we going to do? We are going to divide, well, yeah, we'll do it that way, divide by 2. So let's see, divide by 2, divide by 2. 2 divided by 2 is 1, that leaves us with just an x. And 2 divided by 2 is 1, so x equals 1. All right, that was that problem. Now, okay, so let's take a look at another problem. This one's a little bit different. As you can see, y is being divided by 2. So I think I probably stumbled a little there because the dog started to bark and Mr. Horn came home from work. So here I am. I'm really here now. Okay, so we're going to do another problem. This one's slightly different in that y, our variable, is being divided this time. instead of being multiplied like the last couple we did. So we have the same steps though. Move the constants, meaning add or subtract, use the opposite operations, keeping the equation balanced at all times. So we're going to do the same exact questions. Okay, what is happening to our variable? Well, as far as adding and subtracting goes, we are subtracting 15. So it is being subtracted by 15. What's the opposite operation? To add by 15. Okay, so if we add by 15, over here we add by 15, and I didn't draw my balancing line, so I think I'll do that now. There we go, nice and straight, right? Add by 15, that leaves us y over 2, and that equals 5 plus 15 is 20. Now, at this point, okay, we're looking, then we look at our questions. We did this to both sides. Is my variable alone yet? No, it's not, because it is being divided by 2. So we're going to go on to number 2, where we eliminate the coefficients by multiplying and dividing. All right, so what's happening to our variable? It's being divided, that's a division sign, by 2. So the opposite of that is to multiply by 2, which I'm going to do now to both sides. Multiply by 2, multiply by 2. Just write this down. Don't think about it too hard, that that's what you're doing, because what I find is a lot of students end up doing this. They actually divide by 2 over here instead of multiplying by 2. So we don't want you doing that. All right, so 2 over 1. Okay, 2 times, what it looks like is like this. 2 over 2, y, is really what we get. And that is actually a 1. Okay, so 1y equals 20 times 2, which is 40. All right, so we've got y equals 40. So back down here, is my variable alone yet? Yes, we're done. Yay. Okay, so here's one for you to try. Answer that question. What do we do first? Okay, I'll just tell you real quick. Hopefully you caught this. The first thing that we do is we recognize that what's happening here is it's being subtracted. 9 is being subtracted. The thing we want to do then, 9 is being subtracted. We want to add by 9. That's our first step. So we're going to add 9 to both sides. There's our line. When I add 9 to both sides, I end up with x over 5 equals 3 plus 9 is 12. Now remember, is my variable alone? No, it's not. It's being divided by 5. So what's happening to our variable? It's being divided by 5. So what's the opposite? To multiply by 5. Do that to both sides. That leaves us with 5 over 5 x, which is actually 1, right? That's a 1. And 12 times 5 is 60. So we end up with x equals 60. So we are finished with that problem. Let's go on and you try this one. Okay, good job. I don't think you need me to do that one. I'm going to let you do another one. More practice. Remember, use those little questions here, those little statements and questions. Fill those in if you need to on a piece of paper to help yourself. Read them out loud. Okay, one more. You can do it. And that's it. You can now solve equations 1 step, 2 step. Now, many steps later on. You can do it. All right, show what you know in the next step of our lesson. Thanks for watching.